Hey guys, welcome to Simply Electrical. We're going to be covering non-coincident loads from Article 220.60 of the NEC. There's a ton of confusion over the wording and meaning of this section, and we'll see why shortly. This is mainly geared toward the 2023 code cycle. However, we won't just hit the 2023 requirements, but also the 2020 and pre-2020 stipulations as well. That's because Article 220.60 was left pretty much completely unchanged for many code cycles down throughout history. That is until 2020. In 2020, they added a sentence at the end of the section that really threw a monkey wrench in our understanding of their intent. And folks have been confused ever since. Now, in 2023, they've even made more changes to the section, which we're going to delve into. In case you wonder about your jurisdiction, here is a map provided by the NFPA. So you can see as of March 1st, 2024, 11 states are still under the pre-2020 code. 27 are under the 2020 edition, and 8 states have adopted the 2023. This video will discuss Article 220.60 as it is applied under all 3 periods. Now I'm down here in Texas and we're under the 23 code. Now this video is a deep dive, so that means I'm going to take the time to get into all the nitty-gritty details. And since we're covering multiple code cycles here, there will likely be parts of this video that don't apply to you, so feel free to use the timestamps to jump around. Okay, let's get into it. First, as a reminder, this code section is specific to feeder and service load calculations. Now let's begin by defining what a non-coincident load is. So it's basically any 2 or more loads that do not coincide with each other in their time of operation. In other words, they don't run at the same time. So that's pretty simple. And a simple example of that would be like if you had an open sign and a closed sign for a storefront window. For obvious reasons, the open sign and the closed sign would not normally be lit at the same time. So let's take a look at this first sentence by itself, and then we'll take the second sentence later. Okay, it says, if it is unlikely that 2 or more non-coincident loads will be in use simultaneously, using only the largest load or loads that will be used at one time for calculating the total load of a feeder or service shall be permitted. Okay, so that's pretty simple. It's a bit wordy, but it still makes sense. So a paraphrase would be, say, if you have non-coincident loads that won't likely run together, use the largest load for your calculation. Okay, now back to our example. If you have an open sign and a closed sign, they're not going to operate at the same time. That wouldn't make any sense. So these are non-coincident loads. Now your open sign is, say, is 100 watts and your closed sign is 150 watts. Okay, obviously you can see the closed sign is the larger of the 2 loads. So what we would do is simply take the larger one and leave out the smaller one. So our total would be 150 watts because that is the largest non-coincident load. So that's really easy, right? Well, that's because I picked pretty much the simplest example possible. Now, since this only acknowledges the first sentence of 220.60, there's a bit more we still have yet to consider. Another factor that affects non-coincident loads in a feeder or service calculation regards motor loads. So let's take a different example this time that includes motors. We'll take a furnace and heat pump installation. This is by far the most common situation where non-coincident loads appear, especially in dwellings. Now these are non-coincident loads because the furnace heat strips will not operate at the same time as the heat pump. So now that we have motors involved in our calculation, there are some other requirements we need to address. First, let's look at the furnace and heat pump loads individually. 220.51 tells us that we take the furnace at 100%. You can see it says fixed electric space heating loads shall be calculated at 100% of the total connected load. Then we go over 220.50, which refers us to Part 4 of 440. And in Part 4 of 440, this requires that the minimum circuit amps of the unit nameplate be used. So as we can see, we take both units at full value. So if we have a 12,000 watt furnace over here, and we have a 6,500 watt heat pump, we take each of these at 100%. Then according to 220.60, the first sentence, we take the larger of the 2 loads, right? So the furnace is the larger load. And that gives us 12,000 watts in our calculation. But we're not done yet. Now we'll take a slight detour for a minute because I want to make sure that we understand some relevant terminology and provisions. Then we'll get back to our example. Now, as I mentioned earlier, now that we have motor loads in our example, there is an extra element that we must not forget to include. And here's where the confusion begins, so we'll go through this carefully. Now, section 220.50 covers motors and air conditioning equipment for feeder and service calcs. In 2023, they separated motors from air conditioning equipment and established them as two distinct categories. Now, ACs and heat pumps used to all be lumped together under the heading motors, but now we have to differentiate between motors and air conditioning loads. Now, this raises some big questions that aren't clearly answered in the NEC. But before we start asking those questions, let's cover some basics. And we'll start with motors first. Okay, 220.50A refers us to 430.24, 430.25, and 430.26. Now, 430.24 requires that we find the largest individual motor on the feeder or service that isn't part of a multi-motor or combination load equipment and take 125% of its FLC value to use in our calculation. So here's three separate motors, and we would have to take the largest at 125%. Now, 430.25 tells us to take a multi-motor or combination load equipment at nameplate rating. So we take the minimum circuit ampacity of the multi-motor equipment. So that is talking about some kind of a piece of equipment that has more than one motor in it, or a motor and other loads, but it's a package unit. Now, 430.26, that's just for special instances that require permission from the local AHJ, so it doesn't apply to a normal load calc. So in a nutshell, if I was to rephrase this, I'd say that 430.24 says that you add an extra 25% to the largest individual motor and then add up the rest of the loads with it. Now, we've always called this the largest motor rule, and it only applies to multiple individual motors. But 430.25 says that if you have a self-contained package unit with multiple motors or a motor and other loads, then you take the nameplate rating. So this would usually be like an industrial machine or something with motors incorporated into it. You know, something that was likely assembled in a factory. Now, as an aside, do you see what is conspicuously absent here? Neither 430.22 nor 23 are referred to for feeder calcs. 430.22 and 23 both deal with a single individual motor. Since these two sections are noticeably left out here, the implication is that if you have a load calculation that has only one motor, you do not apply the largest motor rule. In fact, you would just treat it as any other appliance. Now, that may surprise some folks, but that's the way it's been for a very long time. Now, just to be clear, that usually won't come into play in a real-world building calc because most every building has multiple motor loads, but it could catch you on an exam. Those are just the types of tricks they try to pull sometimes. Okay, moving on. We've already talked about air conditioning loads a little bit. 220.50b refers us to Part 4 of Article 440, which tells us to take the minimum circuit amps of the nameplate of the piece of equipment. So in our example, we're dealing with an air conditioner, so we take the nameplate MCA. Okay, now here comes the tricky part. Because there were changes made in both 2020 and 23, this can get a little confusing. And since 2023 is my main focus in this video, I'm going to start by comparing the 2023 to pre-2020. Then I'll treat the 2020 on its own afterward. That's because the change in 2020 was revamped to some degree in 2023. Now, I think this will be the most helpful approach since more and more states will be adopting the 2023 edition all the time. And some states will undoubtedly be skipping over the 2020 altogether. So I'll save the 2020 for last. Okay, now let's go back to our furnace and heat pump example to see how this plays out. But let's start by changing it to a gas furnace scenario to start off with. Prior to 2023, in load calcs, we used to treat air conditioning equipment the same as a motor. In other words, it would be included as one of any other motors on the service. So with our gas furnace and heat pump, since these are coincident loads, because they operate simultaneously, we would add them together. But first, because the heat pump is the largest motor on our feeder, we must take the heat pump at 125% and add the furnace to it. So we take the heat pump times 125%, we get 8125 watts, plus we add the gas furnace to it, 500 watts, that gives us 8625. And that's really it. Now, that's a very simple example of applying the largest motor rule. But remember, this is not a non-coincident load here. This is a coincident load. So now let's try a non-coincident load. Let's say the furnace is electric instead of gas. The heat pump is still the largest motor on the feeder, but is now the lesser of the non-coincident loads. The furnace is now larger than the heat pump. In that case, we would take the furnace load alone, and the heat pump would be excluded from the calculation altogether, as if it no longer existed. And that gives us 12,000 watts total. So that means the next largest motor, whether it's a disposal, a pool pump, etc., something like that, that was the load that would be increased by 25%. Because the heat pump has been totally excluded, we go to the next largest load on the service. Now, just so you know the reason that we did this, prior to 2023, Article 220.50 told us to refer to 440.6 for compressor loads. As you can see, they were grouped in with motors and therefore treated as such. That has now changed in 2023. Instead of a referral to 40.6, we are now pointed to Part 4 of 440. See how they've split the section into an A and a B section, divorcing air conditioning from motors? This changed the way air conditioning equipment is perceived and applied in a load calc. And we'll talk more about this in a minute. But this is how we've treated the non-coincident loads and largest motor loads in a feeder calc up until 2020, when the NEC added that sentence at the end of 2020.60. And then they did further editing to that sentence in 2023, when they separated air conditioning equipment from motors. So now let's see what changed. So far, we've only covered the first sentence of Article 220.60. Now let's look at the second portion. Okay, it says, if a motor or air conditioning load is part of the non-coincident load and is not the largest of the non-coincident loads, 125% of either the motor load or air conditioning load, whichever is larger, shall be used in the calculation. Now, if you're confused, you're not alone. This sentence is problematic. And I'm not trying to be overly critical of the code making panel because I know how easy it is when editing to mistakenly add or leave out key words or phrases, or to overlook the obvious just because you're so absorbed in the subject. Trust me, my own videos are a testament to the ease of making ample editing blunders and oversights. But that being said, we have to parse through this sentence and try to figure out what their intention really is. So let's take it a piece at a time, and to do this, we'll use an example to work with. Now, we've got our same two pieces of non-coincident equipment. We've got a furnace and a heat pump. Okay, now we're going to work through three different scenarios in order to hone in on the meaning here. First, let's take it at face value as much as we can, and then we'll see what would happen. So it says, if a motor or air conditioning load is part of the non-coincident load, which is what we have an air conditioning load here, and it's part of the non-coincident load with the furnace, and it is not the largest of the non-coincident loads, which is true, it's the smaller of these two non-coincident loads, then 125% of either the motor load or air conditioning load, whichever is larger, shall be used in the calculation. So they're telling us 125% of the air conditioning load, because in this case, that's all we have. We don't have a motor other than the air conditioning. And so we take it at 125%. And so our 6,500 watt heat pump would be 8125 watts. And it says we have to use that in a calculation. Well, here's the problem, and it kind of deals with this little clause here, whichever is larger. Because what it says in proper grammar for English is that whichever is larger clause actually applies or refers back to the motor or air conditioning load, but that does not make sense because we're not comparing motor and air conditioning loads here. We're comparing, well, we're supposed to be comparing non-coincident loads. And perhaps that's what they meant it to mean, but that has its own issues if we take it that way, and we'll talk about that in just a bit. But what it's telling us is, if you notice, this second sentence is not written as an exception to the first sentence. It's written in addition to it. So we have to take both these sentences and apply it to our calculation. Therefore, we have to take the largest of the non-coincident loads, according to sentence 1, and also 125% of the non-largest of the non-coincident loads, if it's a motor or air conditioning load, which it is. So they're telling us we have to take both the furnace, because it's the largest, and the heat pump, because it's not the largest, and it's an air conditioner. So we have to take them both. Now, as you can see, that leads us to a couple of problems. number 1, we've completely abandoned the whole non-coincident load idea, since we're just adding them both together. So instead of comparing the two loads and choosing one, we simply combined them. So the question becomes, what is the whole point in putting this under the non-coincident loads heading? Because we're not even taking that into consideration anymore. We're just adding them together plus an extra 25% for the smaller one. Okay, number 2, the second problem we have here is that 20,125 watts, that is a way overinflated value, because not only did we add the two loads together, we actually also added an extra 25% to the smaller load. It's kind of like a double whammy. Even though this is what the strict wording says, this cannot be their intent with this change. So then what is their intention? Well, it appears that they are attempting to accomplish two things with Article 220.60. Number 1, they're trying to capture the largest non-coincident load, and that's what the first sentence says. But then number 2, with the second sentence, it's telling us if the lesser non-coincident load is a motor or air conditioner, and adding an extra 25% to it causes it to surpass the value of the other load, they want to be sure the motor or AC load gets counted instead, because it now became the actual larger of the two loads. And we'll go over an example that shows that in just a minute. Okay, now why this extra 25%? They say 125, but I think they meant 25. But why do they want that? Well, it seems that they have in mind the motor load being the largest on the feeder. And the reason I say this is because of a particular clause that they had added to the 220 NEC. And that clause says, if it is the largest motor, which implies the largest on the feeder. Now, this clause was mysteriously omitted in 2023, even though the idea is still implied. And we're going to talk about the 2020 clause in a minute, actually near the end of the video. Okay, but that's part of the problem here, because of this omission in 2023, they don't mention anything about the size of the motor or AC in relation to other motors on the feeder. And since it's not clearly stated, we have to scratch our heads over it and try to do a little mind reading. Now, 3 big questions arise here. Number 1, what if there's a larger motor elsewhere on the service, like say a pool pump? Would the 125% still apply here? Okay, we don't have an answer to that the way it's written. The second question was, if it's an AC, why would they use 440.33 instead of 440.35? Because 440.33 applies to individual compressor motors, but 440.35 applies to package units like an AC. And when you have a package unit, there's no additional 25% required, and that's because that's already accounted for in the nameplate rating of the unit. So that doesn't make sense either. Okay, now the third question that arises is, what if your largest non-coincident load happens to also be a motor load? And what if it's the largest motor on the service? Do you still take 125% of the smaller motor? According to this wording, you would. So that doesn't make sense either. So these are just 3 of the main big questions that come up that can't be answered by the way this section is worded. So this single sentence is just a whole can of worms by itself. Okay, so now I want to show you how I approach this code section. And let's quickly take a look at 2 more examples. Here is the same example, but with a different interpretation. I believe this is what the code making panel intended to convey. Our furnace is the largest non-coincident load. Instead of adding 125% of the heat pump load, we only add 25%. And only because it's the largest motor on the feeder, 25% of 6,500 is 1625 watts. This way, our largest motor rule still applies to the actual largest motor on the feeder and gets accounted for, even though the heat pump load itself is not computed. So we come up with 12,000 watts for the furnace plus 1625 watts for the largest motor portion, giving us 13,625 watts. Okay, now remember how in pre-2023 we used to treat the lesser non-coincident load as if it didn't exist? Now this recaptures that largest motor's extra 25%. So this is what I believe to be the intent behind the new wording in 2020.60. Now we're actually accounting for the largest motor load on the feeder and taking that extra 25% and applying it to our calculation. Okay, but there's one more thing that this does for us. Let's now see what happens when our two loads are a bit closer in size. Now our furnace is only 8,000 watts. Our heat pump is still 6,500 watts. So our furnace is the larger of the non-coincident loads, just like it was before. However, since the heat pump is the largest motor load on the feeder, we need to apply 125% to its value. Once we do that, it brings it up to 8125 watts, which surpasses now the furnace. So the heat pump is actually the largest non-coincident load after all. That means we simply take that value as our total. 8,125 watts is our total. So this approach captures the heat pump as both the largest non-coincident load and the largest motor load on the feeder. Okay, I promised I'd go over the 2020 rendition of Article 220.60, so let's hit that now. From the map I showed at the beginning, you saw that over half of the states are still under the 2020 code cycle, so it's important that this gets covered. First, I want to show a comparison of the three versions of the article. You'll see here that in 2020, there was no change to the first sentence. They simply added an additional sentence to that section. We'll discuss that thoroughly in just a moment. Now in 2023, they restructured the first sentence a little bit, but didn't change the meaning at all. And then they substantially edited the second sentence, making some profound alterations in meaning and application. We already talked about those, so now let's analyze 2020. Okay, now like I said, the first sentence is unchanged from prior versions. So we'll take the second sentence one piece at a time, and you can see that it's shaded, noting that it was added to the text. Now this is similar to the wording of the 2023 sentence, but it has some notable differences also. Again, we'll use our example to work through as we read this. Now for context, we'll start with the first sentence again. It says, where it is unlikely that two or more non-coincident loads will be in use simultaneously, it shall be permissible to use only the largest load or loads that will be used at one time for calculating the total load of a feeder or service. And then they added, where a motor is part of the non-coincident load and is not the largest of the non-coincident loads, 125% of the motor load shall be used in the calculation if it is the largest motor. The strong implication here is that they mean the largest motor on the feeder. Otherwise, it doesn't make sense. Now, this is in addition to the furnace. Notice that the second sentence again is not an exception to the first. It's in addition to. So we have to take both of these sentences together. If it were an exception, think about the consequences. Then we would be taking only the heat pump at 8125 watts and leaving the 12,000 watt furnace out of the calculation entirely. And that is obviously not their intention. So we see that we have the same problem that we had in the 2023 code. By adhering strictly to the text, we must add the two non-coincident loads together and add the 25% to the smaller load if it's the largest motor. Another implication is that if the smaller load is not the largest motor on the feeder, then the second sentence does not apply at all. So you can see that if we take 220.60 at face value, just how it's written, we come up with, again, 20,125 watts, which is very overinflated because we're combining both loads and taking an extra 25% of the smaller load. And that's just not sensible, and it's a far cry from how we've always treated these loads in the past. But so this is what the actual wording of 220.60 prescribes, though not very precisely. Okay, let's compare it to another. Here is our example on top that we just had, and we'll go ahead and start with our same furnace and heat pump. And let's say we have a 7,000 watt pool pump elsewhere on this service, so that now our heat pump is not the largest motor on the feeder. The furnace is still the larger non-coincident load, so we would take the furnace only and leave out the heat pump entirely. So we get a 12,000 watt total because the heat pump is neither the largest non-coincident load nor is it the largest motor on the feeder. So it completely gets eliminated. That's actually sort of how we did this prior to 2020, except it didn't matter whether or not the heat pump was the largest motor on the service. It was eliminated no matter what, if it was the lesser non-coincident load. Okay, now let's look at the likely intent of the code change and what we're really supposed to do with it. It seems the reason for the extra sentence being added was to recapture the inrush current of the largest motor, which had always been excluded in the past. If they had used the value 25% instead of 125%, this would be accomplished. So the furnace is the largest non-coincident load. Take 25%, not 125, but 25% of the lesser load because it is the largest motor load on the feeder. Add the furnace load to that extra 25%, and we get 13,625 watts. This is what I believe the code making panel had in mind, and this is how I do my 2020 calcs. But you're going to have to be careful though, because due to the unclear wording of the text, this may vary from place to place. Different jurisdictions will undoubtedly interpret this differently. If you're using this in the field, you'll have to check with your own jurisdictional authority to know how they are interpreting Article 220.60. Now, if you're taking an exam, they usually give you hints as to what they expect. If they tell you what the largest motor load is in the building, they likely expect you to take it into consideration in your calc. I really hope they fix this once and for all in the 2026 edition of the NEC. I have submitted a public input request to the NFPA for clarification. Hopefully many others have as well. Hey, thanks guys for watching. I hope this was helpful to you. If it was, please leave me a like, and also, if you'd be so kind, subscribe. That would help me out tons. Check out my other videos on my channel. I've got many calc videos on both the 2020 and 23 code cycles, everything from single family to multifamily to commercial calcs and more. Okay, I'll see you in the next one.